Good morning, everyone. This is the session number 4 from the chapter of alternating current, and this is the Q&A session. And for this session, I have taken a question which is very simple. And the very purpose of taking this question for this session is to revise the basic formulas which we have studied in the session number 2 and 3. So here, in this question, a light bulb is rated at 100 watt for a 220 volt supply. Now, in my previous session, I have already told you that the voltage which is supplied in our households or in the offices, it is the RMS value. That is, this 220 volt is basically the RMS voltage which is equal to 220. First thing. So, second thing is that the bulb is rated for at 100 watt. So the power rating of this bulb is 100 watt. So the first question is we have to find the resistance of the bulb. So in the previous sessions we have seen that V is equal to IR. This was the formula which we have derived, where V is the RMS voltage, I is the RMS current, and R is the resistance. Similarly, we have also derived that P is equal to I square R, where I is the RMS current, that is I is basically the RMS current. So V is the RMS value of voltage, and I is the RMS value of current, and R is the resistance. R is the resistance. So in this case, it will be the resistance of the bulb. So now, the first thing which we have to find is the resistance of the bulb. So if I will be using these two equations, that is V is equal to IR and P is equal to I square R. So if I square this equation, that is V is equal to I square R square, then what I will be getting is, that is, it will be equal to V square is equal to I square R square, and the second equation is P is equal to I square R. Okay. So now what I will do is that this is the equation, this is the first equation, and this is the second equation. So I will now do, what I will do is that I will just divide these two equations, that is V square is equal to I square R squared, and V square is equal to I square R square, and P is equal to I square R. So I have divided, so what I have done is, that is, I have divided this equation, these two equations in this way, and so what here, this I square and I square will get cancelled out. R will get, it will this R square, so what I will be getting is V square upon P will be equal to R. So now, using this equation, I will be able to find the resistance of the bulb. So what I will do is now, so R is equal to V square upon P. Now V, the value, now this is the RMS voltage. The value which is given in this question is the RMS voltage. So it will be 220 whole square, that is equal to 220 into 220 divided by P. P was equal to 100 watt. So this is equal to 22 into 22, and or we can say that if I multiply this 22 by 22, I will be getting 484 ohms. So the resistance of this bulb is equal to 484 ohms, the first thing. Now we have to find the peak voltage. So in the previous sessions we have seen that the peak voltage, that is Vm, is equal to root 2 V, where V is the RMS voltage. It is the RMS voltage. So this will be equal to 1.414 into 220. So this is equal to, if I just calculate it, so it will be equal to 220 into 1.414. So this is equal to 311 volts. So the peak voltage is equal to 311 volts, and now we have to find the RMS current through the bulb. So here the resistance of the bulb was equal to 484 ohms. The peak voltage, or we can say Vm, this is equal to 311 volts. And now I have to find the RMS current. Now we know that V is equal to IR, where I is the RMS current and V is the RMS voltage. So I is equal to I, which is equal to I RMS. This is equal to V, or we can say it is V RMS divided by R. So I RMS is equal to V RMS, and V RMS is 220 volts divided by the resistance which we have was equal to 484. So if I divide this, it will be equal to 0.45 ampere. So the resistance of the bulb is equal to 484 ohms. The peak voltage is equal to 311 volts, and the RMS current, that is IRMS, is equal to 0.45 ampere. So this session was basically, or you can say that this question was basically taken for this session in order to revise the basic formulas which we have studied in the session number 2 and 3. So thank you very much for joining this session, and in the next session I will be continuing with a different topic, and that topic will be related to means we will be studying about the pure inductive resistance, and thereafter we will try to solve some different type of numericals in the forthcoming sessions. So thank you very much, for the time being, it's a goodbye to all of you.